Hello students, welcome to Educate. We are going to continue with the same chapter, thermal properties of matter. So in previous lecture we have seen the relation between the coefficients of temperature like alpha L, alpha A and alpha B. Today we are going to study some other new terms like specific heat capacity, then heat capacity, then we will define molar specific heat capacity and other related terms, right? So these are basic definitions, so we can read together, but these are simple, you can memorize and you should know how to write. Like here, the change in temperature of a substance when a given quantity of heat is absorbed or rejected by it is characterized by a quantity called the heat capacity of the substance. Here, entire mass of the substance is taken. We define heat capacity S of substance S equal to delta Q divided by delta T, where delta Q is total heat and delta T is change in temperature, right? Because we assume that initial temperature is T and later on it becomes T plus delta T. Then another term is there. Here, if we take mass M, in that case, if delta Q stands for the amount of heat absorbed or given off by a substance of mass M when it undergoes a temperature change delta T, then the specific heat capacity of the substance is given by S equal to capital S upon M. In previous case, we have not considered M. So here we have to take M into consideration. So it will become delta Q divided by M times delta T. The specific heat capacity is the property of the substance which determines the change in the temperature of the substance when a given quantity of heat is absorbed or given off by it. It is defined as the amount of heat per unit mass absorbed or given off by the substance to change its temperature by 1 unit. It depends on the nature of the substance and its temperature. Its SI unit is joule per kg per Kelvin. And here there is another term, that is molar specific heat. In place of M, we will consider 1 mole. So here it's denoted by mu. If the amount of substance is specified in terms of mole mu instead of mass M in kg, we can define heat capacity per mole of the substance by C equal to S upon mu or 1 upon mu delta Q by delta T. Right. So these terms you have seen. And also there are two types of specific heats. One is CV, another is CP. Right. CV is a specific heat at constant volume, CP is a specific heat at constant pressure, and they are related by CP minus CV equal to R. Sometimes we use J, and J is heat equivalent, so that we will study later on, but specifically we will use it CP minus CV for our calculation purpose. So let's see how. So next point is calorimetry. So what is calorimetry? It is a branch of physics which measures the heat transfer, change in heat, etc. So here the basic concept used is heat given by one substance equal to heat gained by another substance. So principle of calorimetry says that heat lost equal to heat gained. And a device in which heat measurement can be done is called calorimeter. It consists of a metallic vessel and a stirrer of the same material like copper or aluminium. The vessel is kept inside a wooden jacket which contains heat insulating material like glass, wool, etc. So you can read it and then we can make use of our knowledge to calculate one question. So let's read the question and see whether you have understood the concept or not. The question says a sphere of 0.047 kg aluminum is placed for sufficient time in a vessel containing boiling water so that the sphere is at 100 degrees centigrade. Right? So first of all, you should know how much heat this sphere has, and then it is then immediately transferred to 0.14 kg copper calorimeter containing 0.25 kg water at 20 degrees centigrade. The temperature of the water rises and attains a steady state at 23 degrees centigrade. Calculate the specific heat capacity of aluminum. So here we have to find out specific heat capacity of aluminum. Right. So the concept that we have studied, that heat lost equal to heat gained. So here we are going to make use of that, but there will be some more points that we have to take into consideration. Like we have taken a calorimeter, so what is its water equivalent, and other terms we will make use. So let's see how. In solving this example, we shall use the fact that at a steady state, heat given by an aluminum sphere will be equal to the heat absorbed by the water and calorimeter. Mass of aluminum sphere is given in our question, that is 0.047 kg. Initial temperature of aluminum sphere is 100 degree. Now, final temperature becomes 23. It means there is change in temperature of 77 degrees centigrade. So heat capacity, we assume that for aluminum is denoted as SAL. Now, with these facts in mind, we can go ahead. So the amount of heat lost by aluminum will be equal to formula we have studied, that Q equal to ms delta T, where delta T change in temperature. So mass of aluminum and then specific heat of aluminum, then temperature change. So here mass is this much, specific heat we have to find out, and temperature change is given as 77 degrees centigrade. So this is one part. Now mass of water is given 0.25 kg, right, and mass of calorimeter is equal to 0.14 kg, right. Then initial temperature of water and calorimeter is given as 20 degrees centigrade, and now final temperature becomes 23 degrees centigrade. It means there is change of temperature to 3 degrees centigrade. So heat capacity of water is SW. Heat capacity of aluminum is taken as SAL, water is SW, and that is this much. This is fixed value. Specific heat capacity of copper calorimeter is also this much. This is also fixed value. So heat gained by water and calorimeter. So you can calculate separately again by using this formula for water and for copper. So for water, M2SW delta T2, and for copper vessel, M3S copper delta 2. So here delta T2 is the same, which is 3 degree that we have calculated. So we write M2SW plus M3S copper times delta T. We put the values. This is 0.25 kg water, and its heat capacity is 4.18 into 10 power 3, and 0.14 kg copper, and its heat capacity is this much, and temperature change is 3 degree. So this is the amount of heat gained. Heat lost and heat gained must be equal as per the principle of calorimetry. So if we equate the two, heat lost equal to heat gained, then we simplify, and after that we will get SAL equal to 0.911 kilojoule per kg per Kelvin. So I think question you have understood. Now we are going to see change of state. What does this mean? Suppose you have 2 kg ice at 0 degree centigrade, And now if you heat it, suppose some heat you provide, despite that it becomes water and temperature remains 0 degree centigrade. What is happening? Where has this heat supplied gone? So obviously this heat is used up in changing the state. So there is a question, if there is no temperature change, then how can we calculate heat? Because you know Q equal to MS delta T. Change in temperature is needed to know the heat. But in this case, since delta T is 0, so Q will be 0. So what is the formula to determine the hidden heat? Hidden heat means latent heat. So latent heat is found by M into L. Mass, which is being changed, and what is its latent heat. So there is fixed latent heat for ice, so we can calculate, right? Similarly, if we have 100 degrees centigrade, suppose mkg 100 degrees centigrade water, and it is changed to 100 degrees centigrade vapor. This is water and it is changed to vapor when heat is supplied. So there is again question, if heat is being supplied, then why temperature is not changing? So here again same thing is happening. Heat supplied is used to change the state. So here again we will apply Q equal to M into L, where L will be latent heat of vaporization, that will be given. These are fixed values, so you don't have to memorize. So this is how we can calculate total heat. Suppose we just take one imaginary example. Suppose we have, say, minus 20 degrees centigrade ice of mass M, and then it is converted to 0 degree centigrade ice, right? So here if we calculate heat, say it is Q1, so that will be equal to MS delta T. We can apply here, change in temperature we can calculate, right? Then 0 degree centigrade ice into 0 degree centigrade water. In this case, heat supplied will be calculated by Q2 equal to ml, right? Then from here, suppose water is heated to 100 degrees centigrade, 100 degrees centigrade. In this case, if we calculate the heat, so it will be equal to MS delta T, right? Here change in temperature will take place. And after that, again same situation will occur. This 100 degrees centigrade water will convert into 100 degrees centigrade vapor. So in this case again we have to apply the formula Q4 equal to ml, and after that this will convert into vapor, and if temperature is given, in that case you can easily calculate by using formula Q5 equal to MS delta T. So if such a situation is given and you have to find out total heat, in that case these steps you have to follow to reach at the answer, right? So this is the basic concept that we are going to make use, and you know what is melting point, what is freezing point. Here there is one important term, regelation. What is regelation mean? Regelation is very good concept. Suppose you have an ice box, and if you take a thread and you just put it, hold its two corners and try to press it, so you will see that thread goes inside this ice cube, and through that path where it has entered, that is again covered by ice. So that is called regelation. Regelation means when pressure is applied at that portion, ice will melt, means it will melt and it will enter, and then again the water that will lie over it will convert into ice. So here the same thing is given, you can read You will understand. So let's see. Take a slab of ice, take a metallic wire and fix two blocks, say 5 kg each, and at its ends, you can do with your hand also. Put the wire over the slab as shown in the figure. Here there is one figure in which the same activity is shown here. That this is ice cube on which this is metallic wire and there are two masses. Now what will happen? This metallic wire will go inside and it will be covered by ice. Right? So this process is called regelation. And what is its importance? What is its practical use? So let's read it. You will understand. This is skating is one example of it. So here this happens due to the fact that just below the wire, ice melts at a lower temperature due to the increase in pressure. When the wire has passed, water above the wire freezes again. Thus, the wire passes through the slab and the slab does not split. This phenomena of freezing is called regelation. Skating is possible on snow due to the formation of water under the skates. Water is formed due to the increase of pressure and it acts as a lubricant. So I think you have understood what regelation is. Other concepts you understand. The change of state from liquid to vapor is called vaporization. And here one important point. It is observed that the temperature remains constant until the entire amount of the liquid is converted into vapor. That is, both the liquid and vapor states of the substance coexist in thermal equilibrium. You understand what is thermal equilibrium? Thermal equilibrium means the two objects are at same temperature. Now, then the temperature at which the liquid and the vapor states of the substance coexist is called boiling point. So here there is one more concept, that is triple point, in which all three phases, solid, liquid, vapor, coexist. You can read it, you will understand, and the triple point is fixed. So that will be used for different calculation purposes. We will see while doing some numericals. Here some basic definitions are given, like normal boiling point, sublimation, then latent heat. As I told you, latent heat means heat required to change the state without change in temperature, right? So here formula used is Q equal to ml, that is given here. Here same thing as I explained you, the graph is shown here. In these cases I am just making it a little bigger. So here it is clear that up to here we can apply Q equal to ms delta T. Here phase is changing, so Q equal to ml, latent heat is involved. Here again same thing is happening, that here phase change is there. So these are the basic concepts that you can read, you will understand. Nothing is difficult for you. And latent heat of vaporization and other points, it's given here, you can read. And in exam or while doing the question paper, you will be given these values, so you don't have to memorize. Like it's given here, like melting point here, phase change. So solid is converting into liquid. For water, it's given 80 kilocalorie per kg or 3.33 into 10 power 5 joule per kg. Similarly, here liquid into steam. So for water, its value is given 540 kilocalorie per kg or 22.6 into 10 power 5 joule per kg, right? So these things you can observe, and after that, let's do this example. I think question is visual. When 0.15 kg of ice at 0 degrees centigrade is mixed with 0.3 kg of water at 50 degrees centigrade in a container, the resulting temperature is 6.7 degrees centigrade. Calculate the heat of fusion of ice. As water is given, here specific heat of water is given, 4186 joule per kg per Kelvin, right? So here let's see, again we can apply principle of calorimetry. So heat lost by water, so change in temperature, so initial temperature 50 degree, and now what is happening, it settles at 6.7. so ms delta t, or here theta final minus theta initial we can write. So m is this much, s is this much, and delta t is this much. So we have got heat lost. Now heat required to melt ice. Since ice is melting, it means latent heat concept is to be used. So we can apply ml, mass, and then latent heat of fusion. So if it is given, it's okay. If it is not given, then we can evaluate. So here our concern is to get this value. So it's okay. Now heat required to rise the temperature of ice water to final temperature. Now here final temperature means here water and ice both. So here M1 and then SW and theta final minus theta initial. Now let's write the values. So here what is amount of water in the question? It's given 0.15 kg. So we can write that. It's a specific heat, we can write 4186. And now reverse is happening. Here ice is at 0 degree centigrade, and it reaches to 6.7 degree centigrade, right? And it is being converted into water, right? So here heat absorbed we are calculating. So we are applying formula ms delta t. So 0.15 kg specific heat, this much, temperature changes this much. So this much heat is used. So this was heat lost by water, this much heat is absorbed by what? This much heat is absorbed by melting the ice. When ice melts, so its temperature will change here. But in between, there is state change also. So heat required to melt the ice. So this much heat is also there. So you can say total heat absorbed will be this and this. If you don't understand, so I can tell you first what is happening, melting of ice. Here ml is being used. That thing, this heat required to melt ice. So we have used 0.15 into L, right? And then this ice from 0 degree, so it is converted to water, and now it has reached up to 6.7 degree centigrade. So here formula will be ms delta t, mass of ice that is converted into water times specific heat of water times delta t. So second thing here msw, here m and y m1, this is mass of the ice that melts, right? And then sw, specific heat of water, then temperature change. So we put these values. So heat is this much. So we have got these two heats that are heat absorbed from here, and that must be equal to heat lost by water. So if we equate, so after calculation you will get LF equal to this much. I think you have understood. Now here there is another question that is also interesting question, and as I told you that latent heat concept and other things will be used while doing calculation. Here let's read the question. Calculate the heat required to convert 3 kg of ice at minus 12 degree centigrade kept in a calorimeter to steam at 100 degrees centigrade at atmospheric pressure. Given specific heat capacity of ice is this much, specific heat capacity of water this much, latent heat of fusion of ice is this much, and latent heat of steam is this much. So you have understood what all is to be done. So here step will be like this, like this, like this, like this, and like this. So here state change, Q equal to ml, here state change, Q equal to ml, here Q equal to ms delta T, here also Q equal to ms delta T, so here also Q equal to ms delta T, provided we are going above 100 degree centigrade. So here we are not going to above 100, so we will not take this portion, so only Q1, Q2, Q3, Q4 will be involved. Let's calculate it and see if there is any difficulty. I don't think there will be difficulty because you have understood it fully. So mass of ice 3 kg, right? So 3 kg ice, specific heat capacity of ice is given 2100 joule per kg per Kelvin. Specific heat capacity of water is this much. Latent heat of fusion of ice is given in question. Latent heat of steam is also given in question, right? So these are the basic information. Now heat required to convert 3 kg of ice from minus 12 degrees centigrade to 100 degrees centigrade steam. So this is entire heat. So it will be calculated in steps. So first step will be the conversion of ice into 0 degree centigrade. So here what is, we will consider this Q equal to ms delta T, first portion. So we take mass into specific heat of ice into temperature change. So temperature change will be minus 12 to 0 means 12. So we write it here. So M 3 kg, specific heat of ice is 2100 and temperature changes 0 to 12 means 12. So we have got this value. Value of Q1 is 75600 joule. Now then comes state change. In that case we have to apply ml. So 3 kg of ice and its a latent heat is given, so we get this value. So we have got the value of Q1 and Q2. Then again we have to apply here Q equal to ms delta T. So heat required to convert water at 0 degree centigrade to 100 degree. So 3 kg and its specific heat capacity is this much. So we put this value and temperature change is 100. So we get next value. So we have got this much, and then comes again there will be state change, 100 degree centigrade water to 100 degree centigrade steam. Then again we will apply ml. So we put the value 3 kg and then latent heat. So we get this value. Now what is total heat? So that will be equal to Q1 plus Q2 plus Q3 plus Q4, and after adding you will get 9.1 into 10 power 6 joule. I think you have understood fully. Thank you for watching. Team Educate.